Hi, I'm Leonard T. Antipuesto and I'm going to show you how to do the door alarm system and the battery monitoring system. In this video, I already attached the wirings of the power supply and some of the components for the sake of the video only. First, I will attach the potentiometers. All of the potentiometers have 250 resistance. Red for positive and black for negative. Then I will attach the LEDs. The LEDs must have 220 resistance of their resistors. Then attaching the resistor in the breadboard with the LED. After that, we will apply power and ground for the IC. Then I will use the wiper as the negative input in the LM399. Then I will attach the output for each of the LED. I will then test the battery monitoring system. At first, the input 3. I will use 0.5. The input 3 is right here. Changing the value of potentiometer. Here is the lowest, the highest possible it can do. So I will change each of the potentiometer's values to match our door alarm system. Now I've changed the values of the potentiometers here so that it will show the high, medium, and up to lowest value of the battery. Then I will attach the positive 3 into the positive 4. Also in the negative, positive 2 and positive 1. Now we have completed the battery monitoring system, but it does not have any inputs. I will use the input of the door alarm system. Now I will do the door alarm system. First, I will change the values of each resistor. We need one 12K ohms, one 100K ohms, one 500 mega ohms, 500, 5.10 mega ohms, rather, 100K ohms, and a 500 ohms. I will attach power in the switch. Then another resistor for the switch. Then the first switch, this will serve as the trigger for our door alarm system. And a capacitor. The capacitors must have 0.1 microfarads. The polarized capacitor must have 1. Then I will attach the resistor, the 12K ohm resistor in here, in the 555 timer. I will attach the other leg of the capacitor in the reset. I will attach the trigger in another capacitor. Adding the capacitors will charge the circuit and absorbs the energy. So in attaching it in battery monitoring system, if the switch is on, the speaker will be on and the battery monitoring system will have no output since the capacitor, the voltage is using only the power from capacitor. If the speaker is off, the battery monitoring system will be on. I will attach the discharge in the 5, then another in the threshold. I will then use the 100K ohm to attach in here and a power the ground and another resistor for here. I will use the out and attach it in here for the LED. Touch the other end of the capacitor in the ground and a resistor for LED. Then the other end of the LED must be connected in the piezo. I will attach a negative in the piezo. Then I will use the polarized capacitor and attach the other end in the ground. Then I will attach the other end of the capacitor in the control voltage. Now we have completed the circuit for the door alarm system. Now I will try to simulate it. As you can see, the sound from the door alarm will turn off after a few seconds because the alarm is only using the charge of the capacitor. Opening the alarm will turn off the flow of the power from the source. After the alarm went off, the flow will start to charge the capacitor again. So I will use the switch as a reset and do the alarm again. So the battery monitoring circuit must be off if the alarm is emitting sound, and it will be on if the alarm is off and the capacitor is charging. So I will attach the other end of the piezo as the input for the battery monitoring system. And there you have it. As you can see, the LEDs turn on after the alarm went off, since the capacitor is charging again. Turning on the speaker or the alarm will cut the power source in charging the capacitor, and this speaker will only use the charge from the capacitor.